Okay, so hello, good afternoon. My name is Maida Machado. I am a project officer at INEA, one of the executive agencies of the European Commission. I work for the Energy Unit and I manage several Horizon 2020 projects dealing with photovoltaics and building integrated photovoltaics, one of which is the Bismarck project. And first of all, I would like to thank the coordinator for having invited me to be here today. As you know, the building sector is one of the largest energy consumers in Europe, and it is responsible for more than 1/3 of the greenhouse gas emissions. A refurbished and improved building stock in the European Union is thus key for a decarbonized energy system. The renovation of public and private buildings is an essential measure in this context. And it has been identified by the European Commission in the European Green Deal as a key initiative in order to drive energy efficiency in the construction sector and contribute to a full decarbonization by 2050. To reinforce this vision, the European Commission has also published a new strategy to boost renovation called a renovation wave for Europe, which aims to double the annual energy renovation rates in the next 10 years. These renovations will, of course, enhance the quality of life, reduce Europe's greenhouse gas emissions, and create additional jobs in the construction sector. Building renovations should also speed up the integration of renewables in buildings, and in particular, the integration of photovoltaics needs to be a key element in this strategy. So, in this context, building integrated photovoltaics must play a strategic role because it replaces traditional construction materials with energy-generating construction materials, so that the photovoltaic systems become an essential part of the building, while at the same time generate electricity. EPV elements, as you know, can include roof shingles, windows, ventilated facades, curtain walls, and they can be based on glass, metal, or other substrates. So they are really versatile elements. It is also important to take into account that BIPV systems are multifunctional in essence, which means that in addition to generating electricity, they can provide additional functionalities such as thermal insulation, acoustic insulation, solar control, waterproofing, and BIPV elements can also be aesthetical, meaning that nowadays BIPV modules allow for different colors, different shapes, or surface finishes, which facilitates seamless integration in the building environment. BIPV technology, however, has been hindered in the past years, mostly by high costs, lack of maturity of the technology, or even some reluctance within the construction sector to adopt new solutions. And therefore, it is not yet a mainstream technology. It represents around 1-2% of the global PV market, and maybe these figures are still too optimistic. And for the moment, it is mostly limited to high-end buildings and not the mass market. However, there are efforts worldwide by manufacturing companies, research centers, and in some cases with strong public funding support to demonstrate the technology, to make it visible, and to contribute in this way to a more significant market deployment. In the European Commission, there are several Horizon 2020 research projects running, dealing with different aspects of BIPV technology. And their main aim is to demonstrate the performance, the reliability, the multifunctionality, and the cost effectiveness of the technology. Bismarck project is one of these, And in particular, it is developing energy positive glazing systems, or in other words, multifunctional laminated glass, which produces electricity, but at the same time provides a very good aesthetics for the architectural integration in the building. And the B-Smart photovoltaic glazing can also contribute to the solar control and the thermal insulation, the acoustic insulation, for example, by integrating it in double glazing windows. So these objectives are clearly and fully aligned with the European Commission strategy regarding the climate-related targets and the renovation wave. The technology is now mature, and the main challenge is to step from this still limited market to the mass construction market. In this sense, one of the strongest points of the project is the demonstration activities, in which the energy positive glazing developed in the project will be integrated and demonstrated in operational buildings. This will definitely contribute to an enhanced visibility of the technology amongst architects, designers, the general public, policymakers, etc., which is very positive in my opinion. And additionally, the project is contributing to reinforce the establishment of a competitive BIPV value chain in Europe. BIPV depends on both the construction and the solar sectors, so it is very important that they work well coordinated in order to avoid fragmentation, which would make it weaker and less competitive regarding external competition. Projects like B-Smart involve different stakeholders, from architects to manufacturers, installers, and this is a very relevant contribution to the successful deployment of the technology. The project is, of course, very committed with dissemination and communication, and this exhibition is a good proof of it. So congratulations to the project participants for this. And with this, I would like to finish. I would like to wish you a large success with the exhibition and also with the project. And thank you very much.
Hello, Raphaël. Good evening. It's a great pleasure to welcome you here on the side of the EPFL pavilions. We are here today to open for the opening of the What is Art exhibition that we are opening now in the context of the B-Smart project. The B-Smart project is a European project, and it's all about solar energy, architecture and art. And with this exhibition here, we want to talk about the results of the project, what we can do and what is the potential of these technologies. I really want to welcome you warmly. It's really a great pleasure to be here. I also want to congratulate and to thank all the project partners that makes this possible, and especially today Compass with Raphaël Pizzera, who's here now with us, because Compass is the initiator of this exhibition. And what could you say?
We are very happy and proud to exhibit our artwork in such a great place, and we hope we can meet physically here, but you can also follow all the exhibition in a 3D and a digital immersion version. So we warmly welcome you, and please enjoy this great exhibition.
Let's come in.
Please.
So what a beautiful day to visit this new exhibition here, What is Art, in the EPFL Pavilion.
Thank you. Yeah, it is a beautiful day for this inauguration. I'm very delighted you could come.
Thank you. And Sarah Kenderdine, you are the director of this EPFL Pavilion here in Lausanne. Could you tell us a bit more about the role of this space dedicated both to art and science, how do these two dimensions combined here.
Indeed. So welcome to the EPFL Pavilions. It's an initiative from 2017 that allows us to bring an artistic lens onto science, to amplify science for society in different ways. We are in a seminal Kengo Kuma building which overlooks the lake. We're able to activate this space with the wonderful weather we are having right now.
And what about this exhibition, What is Art, is a bit special because it's dedicated to an industrial object, more precisely an industrial technology. So how do you see this complex link between art and science, between art and technology? And more precisely, what is the place of an industrial technology here in this artistic center?
The history of the development of art or the creation of artistic work is using the tools of the day. This is a new product which is emerging, which gives artists an opportunity to do a reframing of that, to make comments on both how the science might impact our lives, which is what this exhibition is really about. And this has been the whole history of art making, actually, is to use these new emergent projects and products, or soon-to-be products, in this kind of way.
And in this sense, is the role of art, or do you see the role of art also as a way to promote technological progress and scientific research?
So it gives us a language for society, a new language for society to be able to understand complex scientific projects and also how it may impact their lives. And this is really an important aspect of integrating new science in society, much as we would imagine that some of the science here could be.
Interesting. And there is something really interesting here as we discover these integrated solar panels, because of course they're efficient, and we'll come back to that point later, but they're also and mostly aesthetic. And in the same time, they represent a lot of things because they represent progress, technological evolution, and a perspective in terms of sustainability. So which axis touches you the most between the aesthetic dimension of the product itself and what it represents in terms of sustainable perspective?
I think this is where the art and science meets, if you like. These aesthetic dimensions indeed are very important, but its resonances for society are what are articulated through these installations. And when people understand what a big impact it can have on their daily lives, on the way they go about their business, on the health of the planet, these are really, really important messages for our time. And so sustainability is a really strong aesthetic force, if you like, in this case.
Indeed. And what about the product that we discover here has something really complex, because the technology is really efficient. So specific technological process have been used in order to build and develop this technology with the best efficiency possible to have. But at the same time, talking with architects, for example, we realize that the efficiency of the technology itself is not enough, because to be more widely adopted and more easily integrated into architectural projects, it has to be aesthetic and beautiful. How do you see this aesthetic imperative in terms of the place of art in society?
The role of design, I think, is really important here. We can look at it in terms of Apple Macintosh computer, if you like, which had a very strong human-centered design approach, which allowed it to be adopted in in society over other types of similar technologies.
Yeah.
And so these roles in which design can be used to, especially in the affective dimensions, which is to do with aesthetics, to do with lights, to do with affect on your body, and on the environment in this case as well.
Yeah.
These are really important for uptake, for engaging with these tools, technologies, and whatever in your daily life.
And talking about affect on the body, for example, what kind of impact do you want to generate with this exhibition, and to whom? Because of course, architects are kind of a target audience, if I can say so.
Okay.
But who else do you want to touch with this exhibition, and how?
At EPFL Pavilions, we have a very diverse audience. And we have many members of the public coming, as well as we have architectural tours, actually, of the great architecture on EPFL campus. So often there are tour buses here to look at EPFL architecture, which is really interesting. Not quite so much during this period, but
of course,
in general. And so the idea that you can have an architectural element on display is really perfect for this marriage between the building and the strong architectural presence that it has as the pavilions, and this new framing of it, or this new cladding for it, or this new live architecture component.
Yeah, interesting. And while visiting the exhibition, we can clearly realize the progress and the potential of solar technologies and innovative solar technologies as this one that we discover here. Do you feel like art and an artistic project as this one has the power to stimulate science research and technological progress?
I think that all scientists and all sciences are hugely creative. And the lens that is created here on this science offers new insight for scientists to reframe the way that they might think about a particular topic, about how they might stage these works, about its needs, because all exhibitions reveal needs.
Yeah.
And so this way of bringing the science into public space like this, and to look at its aesthetic distribution and conjunction, actually highlights certain elements that are super interesting, I think, for the sciences, as much as for architects, and as much as for artists themselves, who might use these elements to reframe the discourse.
Yeah. And what about, at the same time, what about the impact of science on art? How do you see the way technological progress and scientific research make the work of artists evolve, and also the visitors' experience evolve?
So, as I mentioned earlier, I think that artists are always using the technologies of the time.
Yeah.
So if they find a technological development, they can incorporate this in their art. The role of EPFL Pavilions is really to work on experimental curatorship, to bring that together with artists and scientists into society. And this reframing and this speculative approach to the science, which artists can do, is really the rationale or the raison d'être of this EPFL Pavilions.
So in this sense, I believe you also see the future of art as a work coming more from technological devices or process, right?
Absolutely, absolutely. I mean, we could draw some well-known examples of how artists, in fact, like Leonardo da Vinci, or working really in a military complex, designing machines for war, while still creating this incredible artistic output from these processes. I think many scientists and artists are both science and art together, because today, to use the tools of technology, you have to understand them. And for an artist, this is really pivotal. And while that also leads to a lot of multidisciplinary stuff, it also leads to transdisciplinary people, the hybrids that are both art and science, that can think in both hats. And I think this exhibition is an example of that.
It's definitely the perfect example, Thank you so much.
Pleasure.
That's really interesting.
Great.
Thanks.